Okay students, so next is our condition for differentiability, right? For question number 9 and 10. If you want to know if a function is differentiable or not, yesterday also I have discussed this, you have to check its left hand derivative and right hand derivative. If they are same, equal, then it will be called as differentiable. The function is said to be differentiable, and not only equal, it must be finite also. Okay, this value and this value both must be finite and equal, because if it is infinite, both infinite, you won't be able to say, right, whether they will be equal or not. Infinite means what? It's a big number. Big number means which value. Big number means which value. In this case, you won't be able to say whether they are equal or not if it is infinite both. Okay, so that's why we used to say finite also. Finite means fixed value you must have. Okay, so that you can confirm that they are same. So I have already given you the condition here. A function f is said to be differentiable at a point x equal to c. Now it is written as domain of f. Domain of f, why? Because x equal to c, whichever you will take point, it must be from the domain of your f. From outside we will not take point. Okay, whatever is the point here in the domain, from there we will take, and we will find out the left hand derivative and right hand derivative there. Okay, so this x equal to c always from the domain. Okay, if left hand derivative and right hand derivative are equal and finite, so you can note this down. Okay, you can note this down. So it's like continuity only. You just have to, in case of continuity, what we used to write is left hand limit, right hand limit, right? Here we used to write left hand derivative, right hand, because this, you can see definition of derivative, right? Definition of derivative was what? Limit h tends to 0 f of x plus h minus fx by h. We used to write this one, right? Principle of derivative, remember this one. So for left hand limit it will come out here minus, and for right hand limit it will come out here plus. Okay, so you find out that at that point x equal to what point they have given, at that point you just check left hand derivative and right hand derivative. If both are same, then it will be called as differentiable, and if it is differentiable, you know it will be continuous also. Okay, so let's do question number 9 and 10. So question number 9, let me write down the question first. So question number 9, you can see what they have said. Prove that the function f, which is given here, fx equal to mod of x minus 1, this is the function given by this, is not differentiable at x equal to 1. Now x belongs to what they have given? Real number, means domain of f is set of real numbers. So you have to check at x equal to 1. Now 1 lies here, right? So we can check this one. Okay, at this one we will check whether left hand derivative and right hand derivative are same or not. If it is same, then f will be differentiable, means it will be continuous also, means the graph will not break. Okay, so let's find out at x given. First write down given. I will give you the format also of writing. Okay, given function, what it is, x minus 1, x belongs to R. Okay, now since it is a modulus function, we will redefine it, right? We will make it into simple function so that we can put the value and can solve the problem. So this can be written as x minus 1 when x less than 1. I hope till now you have understood how to write this. If you take x equal to 1, suppose, what you will get? 1 minus 1, 0. Output will be what? 0 only. Modulus of 0 is 0. So whatever x minus 1 it is inside, outside also, means output also will be same. If I put 1 in place of x I have taken 1, then what will be the output here? 1 minus 1, 0, which is equal to nothing but 0. So you can see inside whatever I got, output also same, means x, if you take 1 inside whatever is the input here, output also will be same. So can I say less than, okay, when I take 1, okay, let's find out for all the values first. Then if I take greater than 1, okay, 1 I have taken, right? Output I got same. If I take greater than 1, that is 2. If I take, what I will get? 2 minus 1, 1. Outside what I will read? Same, right? Whatever is there inside, you can see same thing come out, means x minus 1 whatever is there inside for x greater than 1. Greater than 1 you take any values. Whatever value you will take greater than 1, put it here, greater than and equal to also. Okay, 1 and greater than 1, whatever you put here, solve it, whatever you will get here, output also will be same. Means output will be x minus 1 only. Can I say like this? X minus 1 here, let me write down. You can see x, when I take greater than equal to 1, you put the value here in place of x, solve it, whatever is inside that value will come out. So can I write x minus 1 only, because this was there inside, right? So modulus of that value will give you same thing, this one. So for x greater than equal to 1, what will be the output? X minus 1 only. Modulus does not mean anything here, because if you don't put modulus also for greater than equal to 1, if you don't put modulus also, same thing will be the answer. If you put modulus or don't put, same meaning. Means what I can do? Modulus can I write like this? Okay. For less than 1, let's check. 1 greater than 1 we have already checked, right? So we have got this value only. This value we will get. You can check. You put 3 in place of x. Put 3. What you will get? X I have put 3, right? Greater than 1 I am taking. So you can see 3 minus 1. What you will get? 2. Inside modulus what is there? 2. This is what? X minus 1, right? After solving that only I got this one. And if you solve this one, what you will get? 2 only. Means x minus 1 is the output here. Understood? So you take greater than 1 any value, you will get always this one only. Okay. Now less than 1 if you take, what will happen? Less than 1 means let's take x minus 1. If you take minus 1, what you will get? In place of x. In place of x, if I take minus 1, I will get minus 2 here. Now when you solve this one, inside modulus what is there? Minus 2, and this is what? X minus 1. After solving that only we got this one, right? Now output will be different now. Opposite sign. Can you see? X minus 1, what it is inside? Minus 2. But since modulus is there, this modulus will change the value. From minus 2 it will make plus 2. Means opposite sign. So whatever is there inside your modulus here, when you take x less than 1, whatever you take less than 1, minus 2, minus 3, minus 4, whatever you take, it will always give you the output here, always opposite sign. Okay, so that's why for x less than 1, x minus 1, number you will get same, this one you will get same, but sign will be opposite always. See, 2 will be the output, but minus will become plus. So to make that one opposite sign, what we used to put? Minus here. So you can check. We know that this modulus always make the value, whatever value is there, negative or positive, output always will be positive, right? So if I take minus 2 here, what you will get here? Minus 3, right? But output will be plus 3. So see here, that plus 3 I can get from here also. If I take minus 2 here, minus 2 minus 1, how much? Minus 3, right? Minus 3 into minus plus 3. Can you see? So this function which you define here, we have redefined that one like this. For x less than 1, this will be the value for this. For x greater than equal to 1, this will be the value for this function. And those who have not understood this one now also, means you are not watching all the videos, because most of the question we have done. Modulus we have redefined many times. Okay, in continuity also, means in previous exercise, that is 5.1 also, we have discussed modulus function, how to redefine it. Okay, so this is the redefinition of modulus function. Now let's work with it. So they have said that at x equal to 1, you have to check whether the function is derivative, differentiable or not, right? So we will find out left hand derivative, how much it is, and we will find out right hand derivative. So left hand derivative, what is the definition? Left hand derivative, just in place of, in your definition of derivative, in place of 0 only, it will be 0 minus. You know that, right? Why we used to write 0 minus? It means h is tending towards 0 from left. Okay. So definition of derivative was x plus h minus f of x by h. So at x equal to 1, they have asked you to check, right? Limit h tends to 0 minus f of in place of x 1 minus f1 by h. So see here, function is what now? F of 1 plus h. Now simply if you put 0 here in place of 0, what in place of h, what you will get? F1 here, here also F1. So it will become 0, here also 0. So 0 by 0, you know it's indeterminate. And some student used to get confused, okay? Again I repeat, 0 by 0 is indeterminate, but 1 by 0 we will take it as infinity, okay? Means this, the value of this one will be a big number, I can say. Okay, so don't get confused. This we will take it as infinity, not indeterminate. This is indeterminate. Indeterminate means what? This can have different kind of value. I told you, like 5 by 5 also, it is of the form 5 by 5. So 5 by 5, if it is the form, that means 0 0 will get cancelled and you will get 1 here. And it can be of the form 5 by 0 also. 5 by 0, if it is the form, I told you, right, this one in class 11 also and 12 also, while starting continuity I have explained these things. 5 by 0 form also. If it is 5 by 0, we know this is infinity. So this can be infinity also, 1 also, and this is of the form like this also, 0 by 5 also. So if it is 0 by 5, this is 0. So you can see three different kind of value you are getting for this only. So these are called indeterminate. You are not able to figure out what will be the actual value of this one, okay? But in this case, I know that it will be a big number, big value. So that's why we used to take infinity, okay? So don't think that anything by 0 it is indeterminate, it is infinity, okay? But if it is 0 by 0, then it is indeterminate. Got it? So don't get confused between these two. Okay, anyway, so in this case, let's solve left-hand derivative. So f1 plus h. So in place of x, 1 plus h is there, right? So let me write down 1 plus, let me write down here, f of, when it is x, f of x, it is function definition is modulus of x minus 1, right? So let me write down here modulus of x. Now what is x here? 1 plus h. So in place of x, 1 plus h minus 1. I hope you have understood. F of x, right? F of x, what is the definition? Modulus of x. Now you might be thinking, why I'm not using this? When I will put the value, then only I will use this one, okay? I must know in place of x what value I'm putting here, whether it is less than 1 I'm taking or greater than 1 here inside this modulus, right? So here you can write down here itself only 1 plus h, what kind of value you will take? Obviously greater than 1, right? You can put here also, but I'm using this function first, then only I will use this one, okay? So limit h tends to 0 minus f of x. When it is f of x, your function definition is modulus x minus 1, right? X minus 1, f of x, you can see x minus 1. So here f of this is your x, okay? So modulus x minus 1, clear? Minus, now this is f of x, this is your x. So the definition is x minus 1. So that is 1 minus 1. So actually you don't have to use this one anymore here, because since this is directly value, you can solve this one, right? Anyway, 0. Okay, I don't have space here, so let me write down here. Limit h tends to 0 minus, now see here, 1 minus 1, how much? 0 gone, so you will get only modulus of h. Here 0 only, right? Directly you can know the value of this one. You don't have to go for this redefine function. I don't have to go for that. So 0. For this also, I think you don't have to go for this redefine functions, okay? And one more thing, if you want to use directly from here, there will be again a confusion. You can see, not confusion exactly, you can see 1 plus, this will be what? Tending to 0, right? From left means minus 0 point something. So what you will get here? 1 plus minus, it will be minus 0 point something, right? Okay, so first let me show you like this, after that I will tell you that one, okay? So this one, see here, limit h tends to 0 minus means what? You are tending towards 0 from left means which kind of value you will take? Minus 0.9 999 like that, right? Very close to 0 but on your left. So on your left minus value will come, right? So minus value means h is negative here. See carefully, h is negative here, right? So if it is negative, output will be what? Obviously positive, right? So whatever is there inside, exactly same output you will not get. You will get opposite sign. So what I will write? Minus h by h. Can I write like this? So what you will get here? H is gone. You don't have to put limit value anymore, right? 0 minus. You don't have to put 0 anymore here because it become 1 now is equal to, let me write down here, h tends to 0 minus 1. But if you simply put 0 here, then you know that it will be indeterminate. But we are not putting 0 here. What we used to put is very close to 0 on your left, whatever is your value, that is minus 0.999, those kind of value we used to put, right? And we will check where it will tend to. So you will see it will tend to 1. Answer will be 1 here. Now another way is directly you can use this redefinition. Now here I have not used this one because I don't find it necessary here, but I can use this one directly here. You can see here f of, this is your x now, right? So what kind of x value it is? Greater than 1 or less than 1, you try to find out. Now see here this one, 1 plus h, what kind of value will take here? Is minus 0 point something, right? So if it is minus 0 point something plus minus, it will become minus. So 1 minus 0 point something, what you will get? Obviously 0 point something only, right? So 0 point something means x value is less than 1. So what will be your function? This one. Okay, so f of this, which one I will take? This one I will take. Okay, so let me write down in another page. So both the method I am showing you. Okay, so you can see in this case, without using this redefinition, I have solved the problem, right? But using definition, but why I'm doing this? Because some student may get confused by that in continuity, all the time I have redefined this one and I have used that definition only, right? You can do that here also. So I'm showing you that also. Okay, so see here, left hand derivative, when you will find out, limit h tends to 0 minus f of 1 plus h minus f of 1 by h. Now f of x, now this f of x, two definition is there, right? F of x, when your x, this value is less than 1, this will be your f of x, function will be this one. When your this value is greater than equal to 1, x, right, x is greater than equal to 1, then this will be your function. So let's find out, this is your x here, right? So let's find out this will be less than 1 or greater than equal to 1, right? So see here, if I directly find out here itself, h is what? Tending towards 0 minus. 0 minus means less than 0 you will take, obviously on your left, that is minus 0.999, like that you will take value, right? So suppose 0.99 you will take, minus 0.9. So plus minus it will become minus. So 1 minus 0.999, 1 minus 0.99, what you will get? Obviously 0 point something you will get, right? 0.0001, like that you will get here. So 0 point something means what? This value is less than 1. This value is, you can see x, less than 1 it is here. So if it is less than 1, f of x, which function it will be? This one. So I will use that one there. H tends to 0 minus f of this, what I will write? Minus x. Now what is your x here? 1, right? They have asked you to check at 1. X minus 1. Okay, oh sorry, x is 1 plus h. Let me write down here like this. This will be your function, right? So in place of x, what you have here? 1 plus h. So 1 plus h. This is your x here. Minus 1. I hope you have understood why I'm taking this function now. Fx equal to this one I'm taking in place of this. Why? I have already explained this. After you solve it, what you will get? 0 point something, which is less than 1. Means x is less than 1. X less than 1 means this is the function. So f of this, which function I will take? This one. So in place of x, what you have? 1 plus h. So in place of x, I put 1 plus h. Okay. So minus f of 1. F of 1 means directly equal 1, right? X equal to 1 here directly. So it will be x minus 1 only. Not x, sorry. In place of x, what you have here? 1. again I'm making mistake. X is 1 here, right? So in place of x, 1 I'm taking. Okay, so h. So if you solve this, what you will get? Limit h tends to 0 minus, so 1 minus 1 gone, 0, right? 1 minus 1 0, so minus h will be left out here. Here minus 1, 0 by h. So you can see in this case h has got cancelled. You will get, sorry, this one is minus 1 here, right? Last time I have written 1 only, I guess. Yes, it should be minus 1 here, minus 1 here. Okay, so here you will get minus 1. So directly you got minus 1 means what? No need to put h anywhere. You don't have to substitute here, right? 0. So the answer will be here minus 1. Okay, so this way also you can solve by using redefined function. Okay, or you can do this one also directly in this case, but it's better if you redefine this one and use this only, because all the time if you do this means you will not have any kind of confusion, because in continuity I have used redefined function, and right now if I use this one only, you will think that when to define this and when not to define this. You will get confused, right? So always better modulus function, redefine and use that only. Okay, but you need to understand that very carefully. Okay, so f of x, this one x. Now this you find out whether it is less than 1 or greater than equal to 1. So I have seen that this is less than 1. So f of x, which one I will take out of this two? This one, less than 1, because we have already got x. This is your x now, right? This is less than 1. So whenever this is less than 1, you can see x less than 1 here function, right? So whenever this portion inside bracket is less than 1, it will be this function. Inside this, if it is greater than equal to 1, then this function. So here we have seen that it is less than 1, so we will use, for less than 1, this is the function, we will use this function. So I have written minus x. Now what is x here? In place of x you can see in place of x, when here it is x, here it is x. Now in place of x, 1 plus h is there, so 1 plus h I have put, minus 1. Okay, again minus f of 1 means x equal to 1 now, right? So whenever it is 1 equal to 1, which one function? This one. So this will be your fx now. So f of 1 will be this function. So in place of x, what you have? 1 minus 1 I have put. So x minus 1 function I am used. Okay, so solve this one, you will get the answer. So let's find out right hand limit also, right hand derivative, sorry. Limit h tends to 0 plus f of 1 plus h minus f of 1 by h. Okay, now this time you see 0 plus means you will take greater than 0 values, right? Close to 0, that is what kind of value you will take? 0.1, 0.001, like that you will take, right? Means positive value you will take. So if you take 0.1, 0.001, those value if you take here, then what kind of value it will give? Greater than 1, 1 plus 0 point something you will get, right? So greater than 1 means this will be the function, second one. So this is greater than 1. Limit 8 tends to 0 plus. This portion is, that is, this is your x now, right? So this portion is greater than 1 means which value, which function I will use? This function. So x, in place of x what you have? 1 plus h. So I'm going to use this one, x minus 1, x minus 1 minus f of 1 equal 1, right? X equal to 1, which function? This one only, x minus 1 only. So x, in place of x what do you have? 1, x minus 1, okay, by h. So 1 minus 1 gone, 0, 1 minus 0. So what you will left out with? Limit h tends to 0 plus, here only h by h, which you will get 1. So you can see your left hand limit and left hand derivative and right hand derivative, they are not same. Okay, and one more thing, don't write both, this also and the last one which I have explained here, this also. Don't use both, okay? Write one of this, either this or this. This I have shown without using this also we can solve this problem. Okay, if you wish you can go for this or you can go for this also. I will suggest better go for this, because most of the time we have used this only, redefined function only we have used for modulus, right? So better you go for this only, one way you try to solve. Okay, and if you have understood, that's good. If you can go for this also, it's good. So here what we will write, since left hand derivative is not equal to right hand derivative, therefore f is not differentiable. Okay, it is not differentiable means what? It is not even continuous. You can check, okay, fx equal to x minus 1 modulus function. You check whether it is continuous or not at x equal to 1. You will see that left hand limit and right hand limit also will not come same. Okay, so this will not be continuous. You can check that one, because I have told you, right, if the function is not differentiable, it won't be continuous also. Number 10. Okay, number 10 you try yourself, okay, otherwise I will show you tomorrow, because the video length is again very lengthy it is. Okay, so I will stop here.